In this video, I just want to do a couple examples. So I want to do an example drawing different conformations of acyclic alkanes, and then with naming, we did some where we went from the structure to the name. I do want to practice a couple going in the other direction. I usually don't do very many examples in that direction because it is considerably easier than in the forward direction. At least I feel that it is. But I kind of want to just go through one so you can kind of see my thought process and how I do it. So first of all, we are going to draw the most and least stable conformations of 2-methyl butane. So we're going to kind of combine those two. I'm going to give us the name of the molecule. We're going to have to draw that out. And then we'll draw our most and least stable conformation in Newman projections. I should specify that. So going from the name to the structure, I always start with the parent. So butane, I know but is 4 carbons, so I know I have a chain of 4 carbons. I'm just going to start numbering on the left. It's your molecule though. If you want to start numbering from the other side, more power to you, but I'm just going to say this is carbon 1, 2, 3, and 4. And then according to the name, I have a methyl group on carbon 2. Meth is 1, so I have a 1 carbon group on carbon 2. So that is 2-methyl butane. So basically just go to the parent, see how many carbons that is, draw those. I always do them in a straight chain or just a straight line, and then number them, put your groups on the right carbon. We can do some messier ones after. So I want to draw this in a Newman projection. And the 2 carbons that we're going to use to be our front and our back are going to be the 2 middle ones. So these 2. And I know on one of those carbons, and you don't have to draw the CH3s, you can leave it, but I just want to show kind of what's attached to it. So according on that carbon, I have those 2 methyl groups and a hydrogen. So when I draw my Newman projection, one of my carbons is going to need to have those on them. And then let me get this arrow out of the way. My other carbon has 2 hydrogen and then that CH3 group. So my other carbon, 2 hydrogens and a CH3. It doesn't matter which you make which. So I'm just going to draw the spots where everything goes and then we'll attach it. We want the most stable and the least stable. I know the most stable is going to be a staggered conformation. My least stable is going to be an eclipsed conformation. Remember, in eclipsed, we have torsional strain. We don't have that in staggered. And then since I want my least stable, when I draw that eclipsed version, I am going to put as much I'm going to give it as much steric strain as possible. So I'm going to make this carbon, the one I just put a big old dot on, my front carbon. You can, you can do either one. I'm going to put the hydrogen on top and the 2 methyl groups on the bottom. It doesn't matter as long as that carbon has 2 CH3 groups and 1 hydrogen on it. Again, make sure when you're bonding the CH3 groups that you're bonding them to the carbons. And then on the back, I need to have this methyl group and 2 hydrogen. And I want the most stable. So I kind of think about, okay, I have a CH3 group. Where do I not want to put that, right? If I put the CH3 group here, I'm going to erase it. I'm going to have steric strain here and here, right? Those groups are pretty close to each other. But if I put that group either in this position or in this position, I really only have to worry about steric strain in one spot, right? And this time it's in this spot. If I would have left it over here, it would have been here. But if I put it on the bottom, I would have it in 2 spots. So essentially, I don't want to put the methyl group staggered between the other 2 methyl groups. So if you would have drawn it, upside down for me, that's fine. right? So just another option. There's different ways to draw these, which is part of what makes grading these so long, takes so long. So let's say I would have done this. And then on the first carbon, I put a methyl group here and a methyl group here. And again, there's different ways you can do it. Where I don't want to put the methyl group on the back carbon is there. Don't put it there. I can put it in one of the other two spots, right? We're trying to draw the most stable conformation. Doesn't mean the other conformations don't exist, but the directions didn't say draw all possible. It said draw the most stable and the least stable. So this would be my most stable. So some version of that where I don't have a methyl group staggered between two other methyl groups. On my other one, I'm just going to draw the front carbon the same as I drew the front carbon on the other one. And then I want to draw my least stable. So I want that methyl group, right? I have one methyl group here. I want that eclipsing one of the other methyl groups. So to make my least stable, I don't want to do what I'm currently doing, right? If I do that, it's still less stable than the other one. It's still a conformation that exists, but I want to draw the worst possible one I can draw. And that's going to have a CH3 group eclipsing another. So I could have either put it there or eclipsing the one on the left. I just chose that side arbitrarily. Oop, that's a hydrogen. Right, this back carbon has two hydrogens in one methyl group. So some version of that where you have a methyl group eclipsing another methyl group is going to be my least stable. So on this one, I have torsional strain because I have eclipsing bonds. Anytime you have bonds that are eclipsing, you're going to have torsional strain. And then we do have steric strain here. And we would say there's lots of it. I do have some steric strain here, just not as much as where I put lots. We won't put lots this time. And then if I go and look at my most stable, I have no torsional strain at all, right? No torsional because it's not eclipsed. Again, we're only going to have torsional strain when I have eclipsing bonds. So no torsional strain. But I do have some steric strain here. Sometimes I think that one of the trickier parts is just going from the structure to a Newman projection. So I want to do one more. I'm just going to give us a random molecule here, and let's do this one. So I always want you to pick, and sometimes I'll actually tell you if it gets too long, but pick two carbons that are in the middle to be the ones that you're focusing on. Like I don't want to pick this carbon and this carbon because I can't show a lot of, the strain if I'm going to pick a carbon that just has 3 hydrogen on it. So I always want you to pick ones that are towards the center. And again, if it gets too big, I'll tell you, but I'm going to pick one and this one. If you picked these two, it's the same thing, right? This molecule is symmetrical, so either one of those two will work. And then we're going to do what we did in the last one, where I'm just going to look at the things that are attached to those two carbons. So this carbon right here, it has actually an ethyl group. So right, there's a CH2, CH3 group, a CH3 group, so a methyl group also, and then there is a hydrogen attached to that. So when I draw that carbon, I need to have an ethyl group, a methyl group, and a hydrogen. And then this carbon has 2 hydrogens on it, and then this methyl group. So when I draw this one in a Newman projection, and I'm going to draw my most stable, but really all we're doing right now is we're practicing trying to get this into a Newman projection. And my most stable is always going to be staggered. Eclipsed is never going to be my most stable because it has steric strain. Staggered versions do not. So I'm going to start with staggered. My front, and again, I'm looking at my front carbon. It's going to have an ethyl group, a methyl group, and a hydrogen. It doesn't matter where you put those as long as they're on the same carbon. So I'm going to put my ethyl group here. Make sure you attach it to the CH2 carbon, not the CH3 carbon. Again, if you attach stuff to the wrong atom, I'm going to mark it wrong because it's not correct, right? If it's not correct, I'm not going to mark it correct. So kind of what I'm talking about, this is incredibly common if you're not paying attention. Sometimes people will do this. Now that carbon that I just attached to my center carbon here that I'm putting the dot on has 5 bonds, so that's not right? Why would I mark that right if it's, you can't do that. And then sometimes people will just like do this, right? Now it's bonded to hydrogen, that doesn't work. So just be careful, right? It does actually matter how you connect your atoms, so please be careful. So back, I have, if we want to check these off here, right? I have this group, that's this group. I have my hydrogen, that's that one. Methyl group, that's that one. So I have all of those 3 attached to it. My back carbon, I have 2 hydrogens and a methyl group. Since I said I wanted to draw my most stable one, I'm not going to put that methyl group between the ethyl and the methyl group, right? I'm not going to put it there. And then my other options, I can put it down at the bottom and then it's next to a methyl and a hydrogen. Or I can put it over here in the upper left and then it's next to an ethyl and a hydrogen. Since I said I'm going to draw my most stable one, I'm going to put it down here, right? We want the group next to the smaller group, not next to the bigger group, and then 2 hydrogens. So again, what we're doing is we're just picking 2 carbons, and then we're looking to see what's attached to that, and then we're putting them in our position. Since I said most stable, I don't want to draw eclipsed, and I want to have the least amount of steric strain as possible. Next, I just want to go through a naming one. So I'm going to give us a name and then we'll draw it. So we'll do a couple. What I think is easier about going in this direction is finding your parent and then numbering your parent. Because if I give you the structure, a lot of times our acyclic ones aren't actually straight, like they curve around and you have to try to figure that out. If I'm given the name, I'm just going to draw it straight. I'm not going to make it curvy. You can if you want, but why would you do that to yourself unless you think it's fun? Maybe you love naming and you want to make it curvy, or you want to make it hard for me to grade. That could be a good reason. I'm going to make Jen pay for this one. It's possible. Just be careful not to goof up in the process. Nonane. Okay. So big name. 4-bromo, 5-isopropyl, 6-methyl nonane. So I'm going to start with the parent. Non is 9. Ane is alkanes, so all single bonds. So I'm going to draw a chain of 9 carbons. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Kind of a trick. If you have an odd number of carbons, if you start down, it's going to end down. If you start up, it's going to end up. So if I started this way to get 9, it has to end up. And that's going to be anytime you have an odd number. So if I have 5, it started down, it ends down. So you can kind of not really count. I mean, you do, but it's a big difference between like 9 and 5. So if it's odd, if it starts down, it ends down. If it starts up, it ends up. If it's even, it's the opposite. Like if I wanted to draw 4, there I'm starting down, I'm ending up. If I want to draw 6, I'm starting down, I'm ending up. It's just kind of a shortcut for counting them, particularly if you talk while you draw them like I do. Okay, so I have my 9 carbons. I'm just going to number them. I always just go from left to right. Of course, it's your molecule. If you wanted to draw a 9, I'll curving around and start numbering them from some weird spot. It has to be an end, but go for it. And then I just have to put stuff on the right carbon. So on the 4th carbon, I have a bromine. So on the 4th carbon, I'm going to put a bromine. On the 5th carbon, I have an isopropyl group. That was one of our special alkyl groups. So until you learn those, that one's a little tricky. I'm just moving that 5 out of my way. But isopropyl was this one. On the 6th carbon, I have a methyl group, and I'm done. So draw the parent out, number the parent, and then put the parts right in the right spot. So on the 4th carbon, I put a bromine. On the 5th carbon, I put an isopropyl group, and on the 6th carbon, I put a methyl group. Let's do another one. So let's draw trans. One chloro. Oops, sorry. I didn't make this one up ahead of time. I was about to break a rule. So let's do 1 tert butyl. 2 chloro. Did you guys catch what I was doing wrong? I wasn't alphabetizing it. Cyclopentane. So same idea, we're just going to practice drawing this. So I'm going to go to the parent. I always do the parent first. I have cyclopentane for my parent. So I have a ring of 5 carbons. I'm going to number it. You can start any place you want because it's a ring. I started at the top, but again, start wherever you want. And then this one's trans, so I know of the 2 groups, right? I have 2 groups. I have a tert butyl group and I have a chloro group. I need to have one coming out and one going back, right? Trans means they're on opposite sides of the ring. It doesn't matter which is which, I just have to have them opposite. So on the 1st carbon, I'm gonna have a tert butyl group. That was the one where attached to my parent, it went out, and then that was attached to 3 other carbons. I'm gonna wedge this one. If you wanna dash this one, that's fine, but it's gonna go out to its 3 carbons. That looks kind of weird, but anytime you dash a group that has groups on it, maybe that's a little better. It looks a little bizarre. And then on the 2nd carbon, I have a chlorine, which I need to have going back because I need them to be opposite. So let's do another example where I give you the name and then you draw the structure. So this one's pretty long. So 2 butyl, 4 cyclopropyl, 1 ethyl, cyclohexane. So same sort of idea, go to the parent, draw that, number it, and put your groups on. I'm gonna ask you to do this one on your own if you haven't been doing that. So please just hit pause, try drawing it, and then when you're done, hit play again. So hopefully you guys did that. So that does say cyclohexane, believe it or not. So I'm gonna draw a ring of 6. And then I'm gonna number it. You may have started in a different spot than I'm gonna start, and that's perfectly fine. Just be sequential about your numbers. And then I'm just gonna start putting my groups on. So on the 2nd carbon, I have a butyl group. Butyl is 4 carbons. So I have 1, 2, 3, 4 carbons there. So my butyl group. On carbon 2, I have a cyclopropyl group. So this one's a little weird. Propyl is going to be 3 carbons, but the fact that I put cyclo in front of it means that those 3 carbons are actually in a ring. So cyclopropyl. Those bonds got awfully small compared to my other carbon bonds. We could probably make that a little bit nicer, but I would take that. So my 3 carbons in a ring. So propyl 3, cyclo means they're cyclic. So make them into a ring. In carbon 1, I have an ethyl group. Eth is 2, so a 2 carbon group there. And that's this structure.